Hey all. So this video lecture I am recording for preparation of university examination, and this is especially for biotech and chemical engineering students. Chemical engineering. So the physics for biotech and chemical engineering, the subject code is PH25C04. This is the subject code, and the physics is physics and analysis of materials. Physics and analysis of materials. So what I'm going to discuss here, and especially students find it very difficult uh, to answer in university examinations. It's not about answering, it's about the preparation. So students, they don't know how to prepare for exams. They blindly learn certain concepts and they couldn't reproduce it in examinations. That is the difficulty arises. If they learn it properly and have proper understanding, definitely they can do well in examination. So here I want to explain how to prepare for the university examination. For any examination, it may be a model or university or any kind of examination. This method will help you to learn better. So I just split this as we have as we know that we have part A section. So in part A, each question carries 1 mark, and there is 15 such questions. So it is 15 marks. And in part B, the question carries 2 marks. Each question carries 2 marks. There will be 10 such questions. So it is 20 marks. And in part C, so each question carries 13. So multiplied with 5 numbers. Sorry. So multiplied with 5, that will be 65 marks. So the total will be 100 marks. So this is the pattern in which they are going to perform an university examination. So let me split this into two parts. First, I'll speak about part A and part B together, because part A and part B, the preparation was very similar. So I split as part A and part B together, and part C separately I'll explain how to prepare. So first we move on to part A and part B section. So when you prepare for part A and part B, part A and part B, right? So how to prepare for part A and part B? What is the best is the best you should have a proper understanding of all the concept. Proper understanding is required. If you don't have proper understanding, definitely you cannot answer any of the questions in part A and part B. So actually the allowed Bloom taxonomy for part A and part B is BL1 and BL2. So BL1 is remembering and BL2 is understanding. So we cannot take beyond BL1 and BL2 for part A and part B. So definitely it should lies under BL1 and BL2. So what is required is a proper understanding is required, and second thing is you should remember, right? You should remember the concepts. So these two are essential to answer for part A and part B, right? Even the remembering is possible only if you have a very good understanding. And where to gain these two, right? Where to gain these two? This is gained only inside the classroom, right? However, the best is if you are attentive in classroom, then you can answer part A and part B. If you're not attentive, definitely it is really difficult to understand the concept and reproduce it during examinations. So this is the best way to do. But however, most of the students, they prepare only during examination instead of listening in class and other things, right? So I don't want to criticize or tell all those things. Why I'm telling this point over here is, at least in future, whichever subject you are learning, if you want to answer part A and part B better, you should have a proper understanding in class. You should be attentive in class. The understanding can be obtained only from class. When you listen to the talk, you can get the learning. Otherwise, you cannot answer properly. That is the reason why I'm insisting here. And suppose if you couldn't listen to the class, you are preparing at the end, how to prepare. So mostly the part A and part B, right? It is mostly asked from the introduction part. It is mostly asked from the introduction part. So any exam, whichever you appeared earlier in Model 1 or Model 2 or Model 3, you see the questions, most of the questions will be from the introduction. So mainly you focus on the introduction part. And second thing, it will be from the basic definitions, right? Basic definitions. What are the basic definitions in that particular chapter? So those basic definitions you concentrate. So first thing you see, in all the subject, there will be certain introduction. See to that introduction. What are the introduction in that chapter? And in all the chapter, there will be certain basic definitions. You just highlight what are the basic definitions in that particular chapter. And third, right? Third thing, it will be from the applications part. Applications, right? Whatever we learn here is materials and analysis, right? Physics and analysis of materials. So definitely these materials will be analyzed in order to use it for certain application. So what are the application? So the application part can be asked. So these three, right? In application, it won't come under BL3. Actually, we know that BL3 is application, but it won't be come under us to this level, applied level. So basic, for example, name the application, right? What are the application of Hall effect? You are going to name the application, but you're not going to explain how it is applied. Okay. So if you are going to write how it is applied, then it comes under BL3. Okay. But now we are going to just say what are the application. In that case, it won't come under BL3, it comes under either BL2 or BL1, depend upon the question, how they are pushing. Okay. So part A and part B, definitely it lies around these three, right? Introduction, what are the basic definitions, what are the applications. So let me begin with unit 1, right? So in physics and analysis of material, the unit 1 is, in unit 1 you have conducting materials, right? So conducting materials. So you remember what are the concepts it is there in unit 1. Unit 1 we have conducting materials. The second part we have semiconducting materials, right? We will be having semiconducting part. And what is the third part we have? The third part is optical materials. So unit 1 alone little bit right, large unit where we have three different part. Of course, there is an introduction for all the three, right? All the three topics. So let me tell you one by one. The introduction part for conducting. So introduction for conducting materials. So what are there in conducting materials? So for example, uh, we talk about free electrons and free electron theory, right? Free electron theory. Theories. Actually, we have three different free electron theory. Classical, right? We have classical, quantum, and band theory. So the introduction related to this. So what are free electrons? What is classical free electron theory? How classical differ from quantum free electron theory? What are the advantages, disadvantages? And why we need band theory? Who suggested classical theory? Who suggested quantum theory? Who suggested band theory? And why free electrons are responsible for electrical conduction? Excuse me. So this will be the questions, right? So you should get some knowledge or get some input related to this, right? These are the inputs for the introduction, right? And apart from that, here we also be learning about Ohm's law, right? Especially microscopic form of Ohm's law. Microscopic form of Ohm's law, right? What is microscopic form of Ohm's law? J equal to sigma into E. There are certain relations. Those relations you need to have it in mind. And apart from that, you have another relation J equal to NeVd, where Vd is drift velocity and N is density of electrons, not number of electrons. Number of electrons per unit volume, or we can say density of electrons. And this J is current density. So even they may ask, what is the relation between current density and drift velocity? Simply they can make it as a fill in the blanks. You need to write J equal to NeVd. So like that, these relations you have to keep that in mind. Apart from that, sigma is equal to Ne mu. So from this, this is electrical conductivity, this is mobility, and this is again density of electrons. Okay, density of uh, electrons, or we can say density of free electrons. So we can rather write density of free electrons, not the number of total number of electrons, density of free electrons. So E is electronic charge, which is constant. And from this expression, many questions can be asked, right? From this expression. For example, how the electrical conductivity changes with respect to temperature, right? If we increase the temperature, what happens to the electrical conductivity in a conductor? Because here we have conductor, semiconductor, and insulator. So we have three. When you talk about conducting materials, we need to understand the distinguishment between conductor, semiconductor, and insulator. So related to conductor, semiconductor, insulator, how it changes. These things can be asked. And apart from that, the basic definitions. The next concept is basic definitions. I told about the introduction part, right? Introduction to free electron theory and what are the equations. Based on this, some questions can be asked. And the next is, in this part, we have some basic definitions. So some 2 marks can be asked on the basic definitions. Even a fill in the blanks can be asked basic definitions. For example, what are the basic definitions we know? Drift velocity. Drift velocity. So what is drift velocity? The velocity occurred by free electrons in the presence of an electric field. They simply write dash. Dash is the velocity occurred in the presence of an external electric field. So they can ask, right? So either it can be asked in part A section or define drift velocity. Like that they can ask drift velocity, mobility, uh, electrical conductivity, electrical conductivity, thermal conductivity, Weidmann-Franz law, and then we have mean free path, and then what else we have? A relaxation time, collision time, Fermi energy, Fermi function, and what else? Density of energy states. The definition alone. I'm not talking about the derivation part. The definition alone. Energy states, and then the last is density of energy states, and what else? Fermi energy at 0 Kelvin. We can even ask Fermi energy at 0 Kelvin. So you may be expected to write the EF naught, the expression alone. So EF naught equal to h square by 2m 3nc by 8 pi power 2 by 3. So this expression you may be expected to write. So like that, you first of all list out what are the introduction part and what are the basic definitions. Now try to find the answers, right? So what is drift velocity? What is mobility? What is, okay. So that is easy to learn. And even Lorentz number. So definitely you can do well in part A and part B if you list out like this. And the application. So what are the application in conducting, related to conducting? So for example, Fermi function. What is Fermi function? Where it is used? So Fermi function is used to find out the probability, right? Probability of an electron, rather free electron, occupying an energy level, right? This is also an application. It is applied. So you should know about what is f of e. F of e is equal to 1 divided by 1 plus e power e minus e of divided by kBT. This expression you should remember. And like that, even we can write density of energy states. Density of energy states. For what it is used? It is used to determine the charge carrier concentration, right? That is the purpose of determining this charge carrier concentration. So like that, you should say about the application part, where it is applied, what it is applied. So these are all applications, right? What are these? These are all applications. So simply I'm telling about the applications of these concepts, and there are many other applications, right? It is related to. So like that, you list out what are the applications, definitely you can answer well. And to sum up in semiconducting, now we move on to the semiconducting part, because in this unit we have three different parts, right? So semiconducting materials. Semiconducting materials. In semiconducting materials, what are the concepts you have? So in semiconducting, the introduction part. Introduction. In introduction part, we have the properties of semiconductor, right? Of course, you should talk about the properties of semiconductor. A semiconductor, what are the properties? It is a covalent bonding. It is a material having strong covalent bonding. And in the presence of temperature, when the temperature is increased, free electrons created by exciting the free electrons from valence band to conduction band. The bond will be broken and it is excited to the hydrogen level in order to create the free electrons. And this is a material having energy gap, right? Eg. Whereas if you talk about a conductor, in conductor there is no energy gap, right? It overlaps. So this is valence band and conduction band overlaps. And here the energy gap is less than 3 electron volt. There is an energy gap which is less than 3 electron volt. And if you talk about insulator, the energy gap is much larger than 3 electron volt. In general, we can speak. So like that, you need to list out what are the properties of semiconductor. That is one thing. And apart from that, we can talk about what is intrinsic semiconductor, right? And we can compare that with extrinsic semiconductor, and elemental semiconductor, compound semiconductor, direct bandgap semiconductor, indirect bandgap semiconductor. So mainly we discuss this, right? Apart from that, in extrinsic, we have certain types. So N-type and P-type. So how N-type is formed and how P-type is formed, what are the dopants we add, right? So what kind of dopants we add, this we need to discuss. Excuse me. So these are the concepts, right? If you can learn, address all these answers for all these questions, definitely the questions will be from this, right? And so this is the introduction. And when you talk about some basic definitions, so is there any basic definitions here? I think the intrinsic semiconductor, extrinsic semiconductor, those also comes under the basic definition. What is intrinsic, extrinsic? Some basic definitions. So the basic definitions, there is no specific basic definition. However, what is intrinsic? Right. So what is intrinsic semiconductor and what is extrinsic semiconductor? And what is direct band gap, indirect band gap? So the same applies even for basic definitions, right? So however, in introduction, we'll be discussing about the concepts related to intrinsic, extrinsic, and even we can write what are the basic definitions and applications, and even apart from this, Hall effect. Hall effect. So the basic definition for Hall effect can be asked. And what else? What else we have? And okay, these are the concepts that will be asked. And apart from that, the applications. Even in application, what is the use of Hall effect? In that manner, there can be some questions. For example, the material, what is the method to find out the type of semiconductor, the type of extrinsic semiconductor, right? What is the instrumentation technique which is used to find out the type of extrinsic semiconductor? That is Hall effect. That is and we know that it is based on the Hall coefficient RH. If the RH value is negative, then we know that it is N-type. If the RH value is positive, then we can say it is a P-type. So like that, these differences can be understood from this particular value, right? So these values will be helpful to determine whether it is a N-type material or P-type material. Like that, the application related to Hall effect can be asked. And even, of course, without semiconductor material, there is no electronic industry. The electronic industry is mainly due to the semiconductor material. So that part can be asked. And what else? So the some topics, right? So for example, this so what are the applications of what are the applications, right? Applications of direct band gap semiconductor material, direct band gap semiconductors. Okay, like that, these things can be asked. Indirect band gap because why I'm specifically saying about a direct band gap semiconducting material is